Hello, welcome to the second lecture of our Introduction to Scripting course. I am Wisebon Dankwa. For today's lecture, we are going to look at data types, variables, decision and control structures in batch scripting. Now let's look at data types in batch scripting. There are two data types that are mainly supported in batch scripting. We have the string data types and the integer data types. The string data type basically is an ordered collection of characters, while integer are the data types that we use for mathematical operations. The floating point and Boolean data types, when we talk of floating point, we're talking of the decimal base numbers, and then Boolean, true or false, they are not explicitly supported in batch scripting. So if you want to do floating point arithmetic, you need to go around it with some manipulation statements. Batch scripting can be described as a dynamically typed language. We'll give more explanation on that when we go to variables in our next slides. Now that we've seen the different data types supported in batch scripting, let's look at variables. Variables are just memory locations where we store and retrieve data. A common analogy that's used to describe variables is the box. Consider this scenario. If you have a box, you put your items in it and you can give a name of the box. If you have different boxes, to get an item from a particular box, you call the name of the box and go pick that box or ask someone to bring you the item in that box. Variables are also named spaces or locations in memory. If you want to retrieve the data in that location in memory, you use some operations in addition to the variable name to retrieve the item. These are the rules that are used in naming variables in batch scripting. Now, note that blank spaces are also considered as string data type. So if you give a variable name with blank space between the assignment symbol and the variable name, that blank space is considered as part of the variable names. Also, you can use reserved words as variable names. But here, anytime you use a reserved word or a reserved character, always make sure you use the double quotation. I will advise that do not use reserved words or reserved characters in variable names. Now, these are not rules, but there are some friendly suggestions. The names you assign to a variables should describe what the variables represent. So, for example, in this script here, I'm writing a script to do computation of an area of a circle. Instead of using a variable A to represent the area of a circle, it's better to use a variable that describes what A is. So circle area is a better variable name than A. R should be replaced with radius, since radius describe what the variable represents. Now always ensure that your variable names are not more than 20 characters because it's easy to read and easy to manage as well. Variable names in batch scripting is not case sensitive. So don't forget these rules and suggestions so that you can write good scripts. Now that we've seen what variables are and how to define them, let's look at how we can work with variables in our scripts. There are two main types of variables in batch scripting. We have the environment variables and the script variables. In subsequent slides, we will look at these two types of variables in detail. Now let's look at working with string variables. In order to declare or define and assign a value to a string variable, this is the syntax. You use the keyword or command set. So you start with the command set, then the variable name and the value you want to assign to the variable. Now, how do you access or retrieve the data you stored in a variable? Just use the modulus operator here, surround the variable name with the modulus operator, and then you would get the value stored in the variable. So in this snippet of script here, we have a variable name my name, and I've assigned or stored the value Wisebon in the variable name my name. Now if I want to retrieve the data stored in my name variable, I surround the variable name my name with the modulus operator and I get the value Wisebon. We have now seen how to declare a variable and assign a value to a variable. Looking at string data types, we can have different operations on string data types. Let's look at them one after the other. The first string operation or manipulation we're going to look at is empty string initialization. Since we explained earlier on that blank spaces are part of a string character, you can assign empty strings as blank spaces to a variable. So as you can see here, the syntax for it is set command, variable name, assignment symbol, and then the blank or the blank space. Now that we have been able to assign an empty string to a variable, we can also check if a variable contains an empty string. How do we do that? We use the if command, the variable name, and then we check if it is equal to an empty string. In here, we represent it by an empty square brackets. Then this statement executes. So this helps us to check whether a string variable has an empty string as a data. The next operations we're going to look at are the string interpolation and string concatenation. String interpolation is when we create a new string by bringing together strings, expressions, and characters. So in this snippet of script, what we have done is that we've declared a variable A, assigned the string wage to it, declare a variable B, assigned the string mean to it, and then variable C, we assign the string is to it. Over here, by using A, which means arithmetic, we have declared the variable wage and assigned a numeric data type to it. In this case, 1, 2, 3. Then we interpolate all these data we have into a string and assign to the variable C. With string concatenation, you just form a new string by only using the string data types. So that's the difference between string interpolation and string concatenation. So here, variable name A is assigned hello, whilst variable B is assigned Wiseborn. So our new concatenated string we have is hello Wiseborn. Substring extraction. When you have a string, you can extract subsections of the string. This is the syntax. First, you surround the operation you're going to perform with the modulo symbol, the variable name storing the variable you want to extract from, the colon symbol, the tilde symbol, then the number of characters from where you want to skip. W will be skipped, I will be skipped, and S will be skipped. And from the fourth to the end will be outputted and assigned to my short name variable. We're going to have eborn as the value stored in my short name. You can also use the negative symbol to start from the end of the string. In that case, running this script would output the 3 characters from the end of the string. You can also specify the location within a string you want to extract from. So this is an example. If I run this script 0 up to 3, we're going to keep from the first up to the third characters. That's WIS. In string substitution, you have an original string of characters and you want to replace some characters or all the characters with a new string or a new set of characters. In that case, this is the syntax you use. The original string you have and what you want to replace with, it's then assigned to it. Use the colon operator and surround the whole expression, the modulus operator as well. Let's look at an example. Here, we have the variable x assigned the string value, the sky above is blue. Now we want to replace the word or string gray in the x variable with the new string blue. So we just assign blue to the string gray and then assign the final string we have formed to the variable z. When you output z, the result you get is the sky above was quite blue. Now we've seen strings in detail. Let's look at integer data types or working with integer variables. So to declare an integer variable, you need to start with the /a and then the integer value or the expression. Now the /a transforms the statement into a means to perform arithmetic operation. So you can perform addition, subtraction, multiplication, etc. Without the /a, it's considered every value assigned to the variable as a string. Therefore, you cannot perform mathematical operation. One thing you also need to know is that when you use the /a, then there will be no need for using this symbol surrounding the variables when you want to access their values. Let's look at an example. Now, from this snippet of code, you can see from the first line of code that we are assigning the integer value 2 to the variable x because we use the /a. Now, here also, 8 as an integer value is assigned to the value or the variable y. Expressions can also be assigned to variables if we have the set/a used. So here, the mathematical expression or the operation x plus y is assigned to b. Once again, this modulo symbol is not required when we have the /a in front of the variable name. So here we left it out, but we are not going to get an error. Everything will run without any errors. We can also use it, but it won't change anything. Some people advise using it to make the code user readable or to follow the same format for strings to access variables value. It depends on the programmer or whoever is writing the script. These are some other mathematical operators that can perform operations on mathematical variables or integer variables. So let's look at this example. Here, we are assigning the value x to the value stored in x increased or added by 1. And here, we are assigning 2 to the variable x. Then the next line, we are multiplying the value stored in x by 5, subtracting 3, and then assigning that value to the variable x again. Then here, we output the value stored in x. We've seen how to declare variables, how to use variables in our scripts. One thing that is very important for us to learn or know is that the variables we declare and use in our scripts have a scope. That is, they have a limit as to where they can be accessed in our script. We have the local scope and the global scope. By default, all variables you declare and assign values to in your script are given a global scope. That means they can be accessed in any part of the script. Sometimes you would want to run a program or write a script that a variable should be limited or should have different values in different parts of the script. In that case, you need to specify some parts of the script as a local scope. In order to do that, you need to have setLocal begin the block of code where you want all variables to be local. And then after declaring and using those variables in that scope, you use endLocal. Note that variables declared in the setLocal and endLocal scope will not be accessible outside the scope. If you try to access them outside the setLocal and endLocal scope, you are not going to get any value for the variable. In this example, we assign true to the variable x. Now we print out or echo x, we get true. When we leave the setLocal and endLocal scope and we try to print out x, we are going to get an empty or blank space because it's assumed that we are now trying to assign a value to a new variable x. Everything about this variable is destroyed after we leave the scope. Another example here that illustrates the global scope and the local scope. You can see that here x is a global scope because we have not enclosed it in setLocal here. Now if you output x, we're going to get true. Then we want to say that the x assigned f value should be a local variable. And then we print out that. So when we get into the local variable, we print out false. When we come to access x, we are going to get true because the false value assigned to x is destroyed after exiting the local scope. As you use your computer to perform different tasks, the operating system stores a lot of data about the tasks you are executing and even the users using the system. These information are stored in a special database known as the Windows Registry. Now, the operating system gives you access to the data stored in the registry through the environment variables. Now, environment variables are of two types: user environment variables and system environment variables. The user environment variables are the data stored about individual users of the system, while the system variables provide us information specific to the computer and its execution environment. To see your Windows environment variables, just go to the Start button, go to Settings, About, Advanced System Settings, then you click on Environment Variables. You'd see the different environment variables you have in your system. These are the environment variables we have in our system. We have the ComSpec, OS, Path, PathText, Temp, and WinDir or WinDir. Now these variables plays different roles. For example, the temp is the folder that stores temporary files in the system. The OS also identifies the current Windows operating system on your computer. Now, although we can access the environment variables through the command prompt, we cannot change the variables through that. The only means we can change it is going through the one we described earlier on. And that gives us opportunity to set new values for the environment variables, to add a path to our executables in the environment variable as well. By typing set at the Windows command prompt and pressing enter, you would have a list of all environment variables in your Windows system. In addition to the environment variables explained earlier on, Windows provides us access to a collection of dynamically created environment variables. These variables cannot be seen through the procedure we explained earlier on. The CD variable represents the current directory we are working on. The date variable also provides us the current date of the system. Now, the error level variable helps us to retrieve the exit code of the previous command we executed. So these variables also enables us to perform a lot of tasks. Note that these variables are called dynamic environment variables because their values keep changing from time to time. In subsequent session of our lessons, we would look at how to use some of these environment variables. As you've realized, in all the variables we've declared and used in our examples, the values were assigned to them within the script. Now, how do you assign values to your script at the point of execution? This is the syntax. When you run the program with a script name, don't forget the extension, then you provide argument values that would be assigned to variables within your script. Now, there are two key things you need to know here. If you have a multi-word argument values, you need to enclose them in double quotations. Just like this example, Wise Manfi has a space between them, it's a multi-word value. So you enclose it in double quotation. Same as Cornerbrook, enclose it in double quotation. Now also, when you have to input a null value or a zero-length string, you need to have a blank space surrounded with double quotation as well. How do you retrieve values passed as a command line argument? In your script, you need to use a modulo symbol and a number. These numbers represent the order or the place where the argument is provided. When you use asterisk, it means you are retrieving all the values supplied at the terminal, at the command prompt terminal. 0 is the name of the file. 1 is the first argument. 2 is its next argument in that order. So let's look at another example. Here, we are saying that the first argument that's provided at the command line should be assigned to name. The second one is assigned to city. So name will be assigned Wisebell Manfi, and then city will be assigned Cornerbrook. Then we print out Cornerbrook. Now we've seen data types, variables, and how they are used in programs. Let's go to decisions and control flow. Control flow is basically the steps or the flow of sequence of steps that are executed in a program. To better understand it, let's illustrate it with this flowchart. Flowchart is basically a diagrammatic representation of the flow of logic in a program. This is a flowchart to compute the wages of employees in a company. Now, the system would first take inputs of the hours worked, the hourly rate of the employee, and then make a decision based on the numbers worked. If the hours worked is more than 40 hours, then we need to compute the wage with the overtime rate. If it is less than 40 hours, we compute the wage without the overtime rate. Then the system also checks this. Every employee of the company is required to be paid not less than the minimum wage. So we check that condition here. If an employee earned less than the minimum wage, then we are required to add a 5% bonus to the salary. After adding 5% bonus, if we still don't meet the minimum wage, we continuously add 5% bonus till the employee's wage or salary equals or becomes greater than the minimum wage. Then we output the computed salary for the employee to be happy and smile back home. Now, looking at this flow chart, you would realize that from the first two steps, we are just moving from step 1 to step 2. So this is a sequential flow of logic. Now, over here, we are selecting between computing with overtime rate and computing with the normal rate. That is without the overtime rate. So this is a selection of flow. And here, you would see that if the wage computed is less than the minimum wage, we would continuously be adding 5% bonus to the wage till it meets the requirement of being more or equal to the minimum wage. So this is a repetition flow of logic. In other words, we call it a loop. So we have loops here, we have selection here, and we have sequential. Now, how do we implement all these things in batch programming? Don't forget that we explained in our previous lessons that in batch programming, the commands are executed sequentially from one line to the next line. Therefore, in order to make a selection of which statements or commands to execute, we need to have special keywords to enable us to do that. Or in order to repeat over some sections of commands, we need some keywords to enable us to do that. Let's look at these keywords next. The first command or statement we're going to look at is the if statement. The if statement has this syntax. It checks a condition. If the condition is met, then we execute a task. Let's look at an example. So for example, in this code, we have variables that stores integer data types A and B, or 7 and 3. Then we perform the mathematical operation of summation and assign the values to C. Now we have the if statement to check if the value stored in C is the same as 10, then we output the statement the value of the variable C is 15. If it is 8, then we output the statement the value of the variable is 10. So by so doing, by using the if statement, we are able to select which of these commands are to be executed. Now 7 plus 3 gives us 10, so this statement will be executed, and then we will get the results of the variable's value C is 15. Now we can also have nested ifs. That is, we can have multiple ifs that are put together. If one is true, you check another condition. If all the two conditions are met, then you perform a task. We also have the if-else statement. Recollect that in the if statement, we execute the command if the condition is met. Now, if the condition is not met, what happens? In writing a program, in most times, you would want to have a task performed if the condition is not met. In that case, that task is put under the else statement. So we have the if-else selection statement. Let's look at an example. Here we are assigning 7 to A and 3 to B. Then we compute the summation of the value assigned to A and B, which is 10, and assigned to C. So if the value is 10, then we output the value of C is 10. If it is not, then we say unknown value. So this is the syntax of the if-else. Don't forget that in the if-else, the conditions are always placed in parentheses. So here, this condition should be in parentheses, and this condition also for the else also placed in parentheses. The if and if-else are classical selective statements that runs across almost all programs. In Windows shell scripting, we have other unique cases that we can use the if. For example, we have the if defined, if exists, and if error level. These are the syntax and what they do. With the if defined, it helps us to check if a variable exists. if you have already defined a variable or not. Now, this is the syntax. So let's look at the example. Now we set our variable name, assign Weisborn to the variable name first name. Then we use the if defined to check if the variable name exists. So if defined first name, then we output the string variable first name is defined. The other one is also if exists. That helps us to verify if a file exists. The syntax is if exists file name dot extension of the file, and then what you are supposed to do or what you want to do if the file exists. So one example is this. If exists this file, then we output file exists. The if error level statement also helps us to check the output codes of the last executed command. Now, if your command gives an error, you get a value as 1. If it doesn't give an error, you get a value as 0. So this can also be used in error checking as part of your scripts. So if error level is equal to 0, it means that the command has run successfully. If it's 1, then it means that the command failed. Now, this is a summary of the if statement. So we've seen the if, we've seen if else, we've seen if defined, we've seen if error level, if exists, and if not. The goto statement also enables us to select the line of code that we want to execute. Now, the syntax for the goto statement is this. You have the colon and a label name. Don't forget that once you specify a label that you want to go to, you must have that in a section of the code. You have the colon and that same label name repeated so that the code will jump from the current statement and go to that after executing this command. Let's look at an example. So here we have a numeric or an expression, a mathematical expression where we are assigning 20 to A. Then if the value assigned to A is equal to 20, then we go to label A. If this condition is satisfied, we jump all these steps and then go to label A and print the value is 20. Don't forget that S is a global variable, so if you assign the value to it, it can be accessed in any part of the code. So this outputs Weisborn. That brings us to the end of selection-based control flow. Now let's look at the repetition control structures. For the repetition control structures, some key elements of it are an initialization point where the loop is to start from, then a condition that determines whether the loop or the iteration would continue or not, and then an update or increment operation. So the update operation helps us to continuously update the initialization values so that we meet the condition and then exit the loop. Now, there are two main types of repetition structures. We have the closed-ended type and the open-ended type. With the closed-ended type, we know the number of iterations we have to carry out. For example, if you are writing a loop to print even numbers between 1 and 10, we know the number of even numbers that exist within this range of numbers. On the other hand, the open-ended loops, we do not know the number of times we have to iterate within the loop. For example, if we are performing an experiment of tossing a dice, we do not know the number of times we have to toss the dice to get an outcome of 6. So, writing a loop for such an experimentation would require that we use a while loop. Now, let's look at how the for loop is implemented. In most programming languages, the for loop is implemented this way. This is the syntax for C++. You have the for statement, the variable declaration that serves as the initialization point, an expression, in this case the condition, and an update statement. Then you have the statements to be executed or the statement to run in the loop. Now, in bash scripting, this is how the for loop is implemented. So first you set a counter which will serve as the initialization point. Then you have a label where you can go back to it to repeat the activities or the statements over and over again to get a loop. Now, this is the condition statement or the condition side. If the expression is true, then we exit the loop. If the expression is not true, Then we continuously do the activity we have to do. The increment counter statement is the update statement we spoke about. So all the three elements of the loop can be found here. One, we have the initialization point, the condition point, and the update statement. If the statement or the expression or the conditions are not met, then we go back to the label or up here and start through the loop again. Example snippet of code is shown here. So here we are assigning the numeric value or the integer 1 to I. Then we check the value of the variable I. If it is the same as 5 or if it's equal to 5, then we exit the loop. In that place, we go to the end label. If it is not equal to 5, then we continue with this statement and go to the loop again. So by using the if and go to statements, we are able to implement the for loop in batch scripting. And as you can see in the results, the numbers from 1 to 4 are outputted. 5 is not outputted because when we get to 5, it means the condition is satisfied, so we exit the loop or go to the end section and continue with the rest of our code. Now let's look at other implementations of the for loop. Recall that in the for loop, you need three main elements. We need an initialization point, the condition, and an update factor. Now we have some elements or some objects that these elements are inbuilt. For example, if you have range of values, we have our initial point, which is 0. We have an update or increment or increasing operation, which is, and then we have the condition, that is if we do not exceed 8. So this range of values, starting from 0, increasing by 2 to 8, gives us the opportunity to use the for loop. This is the syntax. /i, double modulo symbol, the variable name, in lower limit, the incrementing factor, and the upper limit, then the operations you have to perform. So when you run this program, you're going to get 0 up to 8. So start from 0, increase by 2, you get 4, 2 you get 6, and 2 you get 8. So that is the use of range values in the for loop. When you have a list of values, you can also write a for loop to iterate over it. For example, here we have a string of names, my first name and my surname. By using this syntax, we can print each name in the list of values we've provided in the parentheses. And this is the syntax. So by writing this in your script, we're going to print the first value, which is Weisborn, then the next value, which is Dankwa. So if you have so many values in the list, we're going to loop over it over and over again and do the activities in the for loop. Now let's look at the while loop. In most programming languages, the while loop has this implementation: the while keyword, a test condition, and statement that are to be executed if the condition is not met, then a termination or an update operation. In bash scripting, by using if and go to statements, we can implement the same logic. Let's look at it. So first we have a counter, that's the initialization state, where we set a counter to an initial value. Then we have a label that we will go to so that we have a repetition or we have a loop. We use the if statement to check if the expression or the condition is met. If it is, then we exit the loop. If not, we perform some operations and then have the increment operation or the update operation. Then go back to the label and repeat the entire process again. Let's look at an example of a code snippet. So here we set the index to 1, set count to 5. And then this is the label that we will go to whenever the condition is not met. So if index is less than or equal to count, then we perform this operation. This is the update operation, which helps us to have an increase in the index value. Now we go back to the while again. Let's look at an example of a code snippet with this implementation. So here we set the value of index to 1 and the value of count to 5. And this is a while label which you will go to whenever the condition is not met. Now we check if the index is less than or equal to count. Yes, it's less than count. Then we perform the action by outputting the value of index on the screen. Here, we carry out the update operation, which in this case is increasing the value of index by 1. Then we go to the while label again and go through the whole process again till the condition is not satisfied. Then we exit the if loop. So if you run this snippet of code, this is the result you're going to get. When the index value is increased to the state that it does not meet this condition, then we exit the loop. And that brings us to the end of the implementation of the while loop. We saw that in implementing the selection and the control structures, we do a lot of comparison in order to decide whether to continue with the loop or perform a selection operation. These are the comparison operators that can be used in batch scripting. We have the equal to, which determines when two values are equal. We also have the EQU, LSS, which means less than, GTR, which means greater than, LEQ, less than or equal to, greater than or equal to is GEQ, and NEQ also determines if one value is not equal to the other. Use these operators in your loops to make it more efficient. This brings us to the end of today's lesson. Today we've looked at data types in bash scripting, variables, mathematical expressions, decision and control structures, where we saw the if, the for, and the while implementation in bash scripting. In the hands-on assignment and lab sessions, we would put into practice all that we've learned in this lesson. See you next week.